Hello, I'm Alhattab Abdelrahim. Me and my classmates will talk about software basics topic. This presentation video for informatics 1 subject. Uh, I will make an introduction video, introduction about software basics. And the name of our team is Electronic Nerds Team. So, what is the definition of software? Software is a set of instruction data or programs used to operate computers and execute specific tasks. It is the opposite of hardware, which describes the physical aspects of a computer, and it's a generic term used to refer to applications, scripts, and programs that run on a device. It can be it can be thought of as the variable part of a computer, while the hardware is uh, uh, the invariable part. There is two main types for software, which is the application software and the system software. The application software is an application is a software that fulfills specific need or perform tasks. System software is designed to run computers, hardware, and provides platform for applications that run on top of, like Windows, Mac, and Linux. So there's also other types of software. There are other types of software, including programming software, which provides the programming tool that software developers need. There's middleware. A software sits between system software and applications. And the fourth type is driver software. Software operates computer devices and peripherals, like video card drive in a computer, and etc. So there's also like we'll talk about these types with more clearly with more details. Examples and types of software. Among the various categories of software, the most common types include the following: the main two types uh, that we talked about, and the other two also. So the first one is application software. The most common type of software. Application software is a computer software package that performs a specific function for a user, or in some cases for another application, or it can be contained or a group of programs that run the application for the user. There's also examples of modern application include Office suites, graphics software, database and database management programs, web browsers, word processors, and software development tools, image editors, and communication platforms like Messenger and social media apps and phones like TikTok and Facebook and etc. The second example is the second type is system software. These software programs are designed to run a computer's application programs and hardware. The system software coordinates the activities and functions of hardware and software. In addition, it also controls the operation of the computer hardware and provides an environment or a platform for all the other types of software to work in. The operating system is the best example of system software. It manages all the other computer programs. Other examples of system software include firmware, computer language translators, and system utilities. So the third type is driver software, also known as device drivers. This software is often considered a type of system software. Device drivers control the devices and peripherals connected to a computer, enabling them to perform their specific tasks. Every device that is connected to a computer needs at least one device driver to function. For example, include software that comes with any non-standard hardware, including special game controllers, or as well as software that enables standard hardware such USB storage devices or keyboard, headphones, and printers. The fourth type is middleware. The term middleware describes the software that mediates between application and system software, or between two different kinds of application software. For example, middleware enables Microsoft Windows to talk to Excel and Word. It also used to send a remote work request from an application on a computer that has one kind of operating system to an application in a computer with different operating system. It also enables newer applications to work with legacy ones. So the fifth type is programming software. Computer programmers use programming software to write code. Programming software and programming tools enable developers to develop, write, test, and debug other software programs. Examples of programming software include assemblers, compilers, debuggers, and interpreters. Uh, so how does software work? All software provides the directions and data that computers need to work and meet users' needs. However, the two different types, application software and system software, work in distinctly different ways. So we will start with application software. So how does the application software really work? Application software consists of many programs that perform specific functions for end users, such as writing reports and navigating websites. Applications can also perform tasks for other applications. The applications on a computer cannot run on their own. They require computer's operating system, along with other supporting system software programs to work. These desktop applications are installed on a user's computer and use the computer memory to carry out tasks. They take up space on the computer's hard drive and do not need an internet connection to work. However, desktop applications must adhere to the requirements of the hardware devices they run on. Web applications, on the other hand, only require internet access to work. They do not rely on the hardware or the system software to run. Consequently, users can launch web applications from devices that have a web browser, since the components responsible for the application functionality are on the server. Users can launch the app from Windows, Mac, Linux, or any other operating system. So we finished the first part, so we'll go to the second part. So how does the system software really work? The system software sits between the computer hardware and the application software. Users do not interact directly with the system software as it runs. in the background, handling the basic functions of the computer. This software coordinates a system's hardware and software so users can run high-level application software to perform specific actions. Also, system software executes when a computer system boots up and continues running as long as the system is on. So what's the difference between system software and application software? System software it has general purpose software that manages basic system resources and processes. On the other hand, the application software uh, performs specific tasks to meet the user needs only. System software uh, written in low-level assembly language or machine code, so it's more near to the machine code. On the other hand, the application software is written in high-level languages such as Python, Java, and JavaScript. The system software must meet specific hardware needs and interacts closely with hardware. With hardware, application software doesn't does not take hardware into account and doesn't interact directly with the hardware. And the fourth difference is the system software installed at the same time as the operating system, usually by the manufacturer. And the application software, the user or admin installs software when needed. And also, the system software runs anytime the computer is on. And on the other hand, the application software user triggers and stops the program when it's needed or when the user needed it. The system software works in the background and users do not usually access to it. And the application software runs in the foreground and the users work directly with it to perform specific tasks. And when the user finishes from it, he can like stops it or cancel this software. The system software runs independently. The application software needs system software to run. And the system software in the access in the necessary for the system function is very necessary for the system function, for the system to function. Another application software, it's not needed for the system to function, it's just needed for the user. So, how the software development life cycle works. The software, mm, development cycle is a framework that the project managers use to describe the stages and tasks associated with designing software. The first steps, in the design lifecycle are planning the effort and analyzing the needs of the individuals who will use the software and creating detailed detailed requirements. After the initial requirements analysis, the design phase aims to specify how to fulfill those user requirements. So the next step is designing. The software design process transforms user requirements into a form that computer programs can use to do the software coding and implementation, which is the next step, by the way. The implementation, it is like where the development work is completed and then we make testing and integration, and then maintain the software. So now we will talk specifically or with more details about the design. There is also types of software design, including the following. There is first architectural design. This is a functional design which identifies the overall structure of the system, its main components, and their relations with one another using architectural design tools. And the second is high-level design. This is the second layer of, of design that focuses on how the system, along with all its components, can be implemented in forms of modules supported by a software stack. A high-level design describes the relations between data flow and the various models and function of the system. The third type is detailed design. It's the third layer of design of the design. It focuses on all the implementation that details necessary for the specified architecture. So, how to maintain the software quality? Software quality measures if the software meets both its functional and non-functional requirements. The functional requirements and identify what the software should do. They include technical details, data manipulation, processing, calculations, or any other specific function that specifies what an application aims to accomplish. The non-function, so the second one is the non-functional requirements, and they also called as attributes, determine how the system should work. So the non-functional requirements include portability, disaster recovery, security, privacy, and usability. So software testing detects, and then we came to software testing. Software testing detects and solves technical issues in the software source code and assesses the overall usability, performance, security, and compatibility of the product to ensure that it meets its requirement. Okay, the dimensions of software quality include the following characteristics: accessibility, compatibility, efficiency, functionality, installability, localization, maintainability, performance, portability, reliability, scalability, security, testability, usability. Like we see, we had like a look about the software quality characteristics, and now we will talk about them with more details. So we'll start with accessibility. Accessibility is the degree to which a device group of people, including individuals who require adaptive technologies such as voice recognition and screen magnifiers and screen magnifiers can comfortably use the software. The second one is compatibility. It's the suitability of the software for user in a variety environments such as the different operating systems, devices, and browsers. Uh, the third one is efficiency. Efficiency is the ability of the software to perform well without wasting energy, resources, or effort, or time, or money. Fourth one is functionality, software's ability to carry out its specified functions. And the fifth characteristic is instability, the ability of the software to be installed in a specified environment. Localization is the various languages, time, and other such features of the software can function in. And the seventh is maintainability, how easily the software can be modified to add and improve features and fix bugs, etc. So the eighth is performance. The performance, how fast, it talks about how fast the software performs under specific load. And the ninth is portability, the ability of the software to be easily transferred from one location to another, and real reliability, the software's ability to perform a required function under specific conditions for a defined period of time without any errors. So the tenth is scalability, the measure of the software's ability to increase or decrease performance in response to change in its processing demands. So the 11th is security, which is very important. The software's ability to protect against unauthorized access, invasion of privacy, theft, data loss, malicious software, and etc. And the and there is testability, how easy it is to test the software, and usability, how easy it is to use the software. Okay, now we reach to performing maintenance. When it comes to performing maintenance, there are four types of changing developers can make, including. First one is corrective. Users often identify and report bugs that developers must fix, including coding errors and other problems that keep the software from meeting its requirements. And the second one is adaptive development. In this case, developers must regularly make changes to their software to ensure it's compatible with changing hardware and software environments, such as when a new version of the operating system comes out. Perfective. In this case, also these are changes that improve system functionality, such as improving the user interface or adjusting software code to enhance the performance. Uh, Preventive. The fourth one is preventive. In this case, these changes are done to keep software from failing and include tasks such as restructuring and optimizing code. So I finished the introduction of software basics. Thank you for your time and for your attention, and I hope that you got useful information about this topic. And thank you very much.
It's Mouhcine. Today I'm going to talk about the importance of software characteristics in software engineering. So to begin with, we have an engineering first consideration when creating any kind of software product is, what are the characteristics of a good software product? Well, before we talk about software characteristics, let's look at what are reasonable to expect from any software. First of all, we have satisfaction. A software product must satisfy the needs of the end user as well as the business. Additionally, we have software development and maintenance should be affordable, so affordability. Finally, we have software development should be completed within the specified time frame, time management. Many software products are available on the market today that serve various industries. Often, software developers focus on creating an excellent product, but they forget to consider aspects that can make a product extraordinary. Maybe you are a software developer who is interested in developing or improving your product, but not quite sure what makes a great one. First, we have large software. Building a wall rather than a house or other structure is much more pleasant in our everyday lives. Software engineering aids in the development of software in a similar way as software grows in size. Scalability. It would be simpler to design new software to scale old software in the software development process was based on scientific and technical principles. Adaptability. It's simple to produce new software within the aid of software engineering. Whenever the software development method was founded on scientific and engineering principles. Cost of the hardware. Industry has shown its skills and huge manufacturing has lowered the cost of the computer and electronic hardware. Dynamic nature, always growing and adapting nature of the software. It depends on the environment in which the user works. Quality management offers better method of software development to provide the quality software products. What you need to know. So, this is the question. What are the characteristics of software? To begin with, what a piece of software delivers and how simple it is to define its qualities. Different people evaluate software based on different criteria. Customers, for instance, desire software that satisfies their unique requirements. Similar to this, software designers, programmers, and maintainers evaluate the internal qualities of the software to determine its qualities. Let's examine them. First, we have functionality, usability, efficiency, flexibility, reliability, portability, maintainability, integrity. So, first of all, functionality. Software capacity to perform and function in accordance with design specification is referred to as its functionality. Software systems should simply work properly, that's it. Carry out all of the tasks for which they were created. The things that the end user and the business expects and standard amenities from the system are referred to as the function. The system needs to incorporate each of these tasks. Although there are many software programs out there that are made to be simple, the main goal of software is to give its customer the functionality they need. Its appearance, components, and feature must all be distinct. If they are too reasonable, the best software products, but there are also goods available that can offer a lot of value for your money. Second, we have usability or user friendly. The user friendliness of software is characterized by its ease of use. In other words, learning how to use the software should require less effort or time. Navigating the software is extremely important since it helps determine the journey the user takes within the software. This is imperative to ensuring visitors to remain on your website and have a positive experience, which leads to an increase in sales and brand loyalty. An important indicator of a good piece of software is its user-friendly. The smooth flow of its design. A product with a great UI or user interface design is more likely to get noticed than one without. If a software program isn't user-friendly, users may have trouble navigating the software and using some of its features. Software should require less time or effort to learn. Ideally, a software should be easy to use even by people with no IT experience. Third, efficiency. Essentially, it refers to the software ability to utilize the human and system resources, such as time, effort, CPU, memory, computation power, network, bandwidth, files, database, etc., as effectively as efficiently as possible. For a software product to succeed, efficiency is crucial. In addition to meeting the needs for which the software was made, it must also provide excellent features designed to assist users in completing their tasks faster. Software should make efficient use of storage space and execute command according to the timing requirement. In order to be efficient, a software must offer user proper value in terms of their time and cash. The market is filled with products that cater to various industries, but only a handful of products are efficient enough to benefit individually and businesses. The medical billing software that Open Practice Solution provides, for instance, make billing process much more efficient for clients than those offered by other companies. Fourth, flexibility. Software flexibility refers to the ability of software solution to adapt to potential of software changes. In its requirement when evaluating the flexibility of software, look at how simple it is to add, modify, or remove features without interfering with the current operation. It's essential to keep up with rapidly changing market technology and customer needs in software development. Changes in is inevitable. It can arise during the development process itself or as the result of future requirements. Flexibility is therefore highly valued. Consequently, any software product must be scalable, flexible, and easy adaptable to future technology. When designing or building a software product, be sure to plan for these changes that are inevitable going to occur. Loose coupling of components is the key to create highly flexible system. 5. Reliability. The reliability of software product describes the likelihood it will operate without failures over a specified period of time under certain conditions. It determines the ability of software that maintain its level of performance, provide desired functionality under specified conditions. For a specified period of time, generally speaking, software reliability is measured as the availability of the software. The value should not be less than 99%. In reliability testing, the goal is not perfection, but achieving a level of reliability that is acceptable before a software product is released to customers. MTTF, MTTR, MTBR, etc. are some reliability metrics that can be used to quantify the reliability of a software product. It is regarded as one of the most important qualities aspects of software quality, along with functionality, efficiency, maintainability, etc. Since software tends to be complex, it is hard to achieve software reliability. Next, maintainability. Maintainability refers to how easy you can repair, improve, and compare software code. In some ways, maintaining is similar to being flexible. Maintain deals with the modification of errors and mirror alternation to software code, while flexibility focuses on major functionality extension. Functional extension. It also involves maintaining the service of functionality of the software. Most of the time, developers are not the ones who maintain the software. Therefore, good documentation is crucial, which includes code documentation, interface definition, etc. Maintainability of software products is affected by the quality of the documentation. Typically, more than half of development budgets are spent on software maintenance. Maintenance should be therefore be integrated in the development life cycle of effective software maintenance. Portability. Software portability is a critical factor that cannot be ignored. Portability refers to the ability to use software in different environments. This is the ease with which software can be ported from one platform to another without or with minimal changes, while obtaining similar results. As simple as this may sound, it refers to the ability of software to work on different hardware platforms without any or little modification needs. Furthermore, you should be aware that porting software to a new environment is comparatively cheaper than developing an equivalent application from scratch. There can be no doubt that portability is a crucial aspect of reducing development costs. 8. Integrity. There are multiple interpretations of software integrity. Some people tend to associate integrity privacy violation to others. High integrity means that the software cannot be modified without authorization. Integrity is key for demonstrating the safety, security, and maintainability of our software. In addition, software that needs to be compliant with Industry regulation and coding standards require high code integrity. Achieving software integrity can be difficult, yet with the right practice to improve safety, security, and maintainability, the challenge can be easily overcome. In these days of increased security threats, all software must include this factor. To conclude, the process of software engineering begins with analyzing the needs of users and culminate in designing, development and testing software that meets those needs. One of the biggest challenges of the software engineering field is ever increasing demand of speeding turnaround times. As we have discussed in this article, there are some characteristics of good software that can make your software stand out from the crowd. The characteristics above are easy to find in a great product due to the today heightened level of design knowledge among the software developers. It simply depends on how well resources are used to produce a high quality software products. The significance of any one of these characteristics will vary depending upon the application. Integrity and reliability factor are paramount in systems where lives are at stake. Whenever developing a business related to application, usability and maintainability are important factors to consider as always when it comes to software engineering. Quality is everything. Create a product that processes all of these qualities and characteristics.
Hello everyone, my name is Sayab Khan and today the topic of my presentation is basic classification of software. So this is the diagram of software. There are two types of software. The one is system software, the other is application software. So computers cannot do anything on its own. It is the users who instructs computer what to do, how to do, and when to do. In order to perform any task, you have to give a set of instruction in a particular sequence to the computer. These sets of instructions are called programs. Software refers to a set of programs that makes the hardware perform a particular set of tasks in particular order. So what is system software? System software is when you switch on the computer, the programs stored in ROM are executed, which activates different units of your computer and makes it ready for you to work on it. This set of programs can be called system software. System software are set of programs responsible for running the computer, controlling various operations of computer system and management of computer resources. Operating system fall under this category. So what is operating system? Operating system is a software that provides an interface for a user to communicate with the computer, manages hardware devices, for example, disk drivers, keyboard, monitor, etc. It manages and maintains disk file systems and support applications program. Some popular operating systems are Unix, Windows, and Linux. And the other type of system software is utility program. So some utility programs are bundled in with operating system software these days. Others you buy or source in some other way. Utility programs tend to perform a specific task related to the management of hardware. For example, antivirus tools, file compression tools, backup and archiving, file managers, disk fragmenters, and disk partitions. So after that, the other type of system software is language translators. Like whatever language or type of language we use to write our programs that need to be in a machine code in order to be executed by the computer. So there are three main categories of translator used and which are compiler, interpreter, and assembler. So what is a compiler? Compiler translates high-level language program into computer machine code or some other low language level. It produces an independent program which is capable of being executed by itself. After compilation, the original translation is no longer needed. So C is the most prominent compiler. And what is an interpreter? Interpreter translates and executes a program one statement at a time. Slower as the analysis of each statement in a loop has to be repeated each time. Java is often called an interpreter, but PHP is a true interpreted language. Assembler translates a program written in assembly language into machine code. Each assembly statement can be converted into a single machine operation. What is library programs? Library programs are compiled libraries of commonly used routines. On a Windows system, they usually carry the file extension DLL and are often referred to as runtime libraries. The libraries are runtime because they are called upon by running programs when they are needed. When you program using a runtime library, you typically add a reference to it either in your code or through the IDE in which you are programming. It's pre-written routine that can be shared by different applications. For example, same printer uses routines used by many programs. For multi-user computer systems, and it is carried out common tasks required by everyone. For example, searching for lost files and restoring corrupted files. And then the other type of computer software is the application software. Application software is a set of programs which are written to perform specific tasks. For example, an application package for managing library known as library information system is used to manage information of library such as keeping book details, account holder details, book issue details, and book return details, etc. Another application package for managing student details is called Student Information System. It manages students' roll number, names, parents' name, address, class, section, and everything. Processing of examination results is also included. Application software can be broadly classified into two types: generalized packages and customized packages. So, what is a general purpose software? Software is a general purpose if it can be used for lots of different tasks. You can use a word processor to write letters, memos, essays, instruction, and lot of more. These days, we tend to use the integrated suite of Office software where a range of general purpose software is provided, usually with the facility to combine elements from each application in a single file. All common application packages, for example, word processing, desktop publishing, spreadsheet, database management, computer-aided design, and presentation packages, is sold as a package including a CD containing the software and manuals. Then come the special purpose application. This software performs a single specific task. This task might be complex like payroll calculation, stock control, etc., but will be based on a single task. It is often used in the tax calculation, income tax return program, accounting, web browser, rendering web pages, and payroll. And the last type of application software is bespoke application. Bespoke software is written for a single client. Large organizations have a need for well-developed applications suited to their specific needs. Such software is often expensive to develop since the development costs are not shared among a large number of people purchasing the software. It is specially written, tailor-made, or commissioned software, and the advantages of bespoke application are it is designed to the exact specification of the user. It can be written to run on a specific hardware. The software can be integrated with existing software, and there may not be a suitable software package on the market. For example, the types of bespoke applications are air traffic control, charging scheme, London congestion, and BBC TV licensing services. So thank you for your attention. Feel free to ask questions. Thank you.
Hey, I'm Ikhlass Kennich and I'm doing the presentation video with my classmates for the Informatic 1 subject and it's about software basics. And in this video I'll talk about software as a critical success factor. Why software is a critical success factor? Because it saves time. Business software applications come with capability of automating several processes, which are otherwise complex and time-consuming to be done manually. These applications save a lot of time and money by accomplishing different tasks in minutes. Otherwise, business need to hire employees to do those tasks. Choosing the right business software can help the company grow by leaps and bounds. Also managing small business software application can handle word processing, payroll, inventory control, bookkeeping, and much more. The software is primarily in charge of handling the tasks of the entire organization. Payroll system. Companies typically utilize numerous sorts of business software. Software is in charge of completing various tasks. The payroll system is critical business software for any organization. This software is essential for managing employees and contractor payments within the organization. This program may compute compensation and tax deduction for each employee in the organization. Effectiveness and consistency. The use of software is essentially for the automation of the organization's tasks, as well as reporting the organization's progress or lacks in its activity. This increases the efficiency and efficacy of the company's operations. The software decreases workload and automates process. It also helps to eliminate human error, which enhances efficacy and consistency. Invoice and billing software. Invoice and billing software is another critical piece of software for business. The software is simple to use and can handle a variety of transactions in their daily operation. You must enter specific client information for the database like before the invoice can be sent to the client. Motivating factor. Business software solutions offer various types and models for business productivity. Increased productivity and profit are the most important and motivating factors for using business software. So all the factors help us understand the important role of software in achieving success at all levels. But we need to know how to protect this software from theft. To prevent that from happening, we should know about software licensing. So what does mean? What does it mean? Licensing and patents. A software license is a legally binding document that restricts the use and distribution of software. Typically, software licenses provide users with the right to own or more copies of the software without violating copyright. The license outlines the responsibility of the party that enter into the agreement and may place restrictions on how the software can be used. So, software licensing terms and conditions generally include fair use, of the software, the limitation of liability, warranties, disclaimers, and protection if the software or its use infringe on the intellectual property rights of others. Licenses typically are for proprietary software which remain the property of the organization, group, or individual that's created. For free software, the user can run, study, change, and distribute the software. Open source is a type of software where the software is developed collaboratively and the source code is freely available. With open source software sourceware license, users can run, copy, share, and change the software similar to free software. Over the last 2 decades, software vendors have moved away from selling software license on one-time basis to a software as a service subscription model. Software vendors host the software in the cloud and make it available to customers who pay a subscription fee and access the software over Internet. Although copyright can prevent others from copying a developer's codes, a copyright cannot stop them from developing the same software independently without copying. A patent, on the other hand, enables a developer to prevent another person from using the functional aspects of software a developer claims in a patent even if that other person developed the software independently. In general, the more technical software is, the more likely it can be patented. For example, a software product could be granted a patent if it creates a new kind of database structure or enhances the overall performance and function of a computer. And here we finish about software basics, and I hope that we helped you to get useful information about this topic. Thank you for your time and your attention.